So in today's video, we're going to go ahead and briefly cover the integral of different trig functions. And so over here, I've written out the derivatives of these different trig functions. So here we have, for example, the derivative with respect to x of tangent of x is just equal to secant squared of x. And so then that tells us that the integral, the indefinite integral of secant squared of x dx is just equal to tangent of x plus c, which makes sense, right? Because the derivative of tangent is secant squared, and hence the integral of secant squared is going to be tangent, and then we have the plus c because it's an indefinite integral. And then we take the derivative of secant of x. We know that that's going to be equal to secant of x tangent of x, and hence the integral, the indefinite integral of secant x tangent x dx is just equal to secant of x. And you can go ahead and cover these ones as well for the complementary trig function. So we have the derivative with respect to x of cotangent, that's equal to negative cosecant squared, and hence the integral of negative cosecant squared of x is equal to cotangent of x plus c. And then the derivative of cosecant of x is equal to negative cosecant of x cotangent of x, and hence the integral of negative cosecant of x cotangent of x dx is equal to cosecant x plus c. And so that was just a whole bunch of talking, but this should just be very intuitive. If you recall the derivatives of these different trig functions, then we can immediately determine what their indefinite integrals are. So let's go ahead and quickly cover a few examples over here. So first of all, we have the indefinite integral of 4 cosecant squared of x dx. And so if we want to go up a little bit over here, we recall that the derivative of cotangent of x is equal to negative cosecant squared of x. And so if we want, we can do this. We can just manipulate this integral a little bit. We can write this as negative, the negative indefinite integral of negative 4 cosecant squared of x dx. And hence that's equal to negative, and then this is going to be 4. And then this right over here is going to become cotangent of x. And then we have the plus c. Right, so we just did a little bit of manipulation over here. We multiplied and divided by -1, if you want to think of it that way, which is totally valid because they would just cancel out when we bring the -1 into the integral, and we ended up with -4 cotangent of x plus c. I encourage you to take this derivative to see that it becomes 4 cosecant squared of x. And then next up we have -1/2 secant of x tangent of x. Again, if you would like to review, the derivative of secant of x is equal to secant of x tangent of x, and hence when we take this integral we can take the -1/2 out, and we obtain -1/2 secant of x, and then plus c. We need the constant of integration because this is an indefinite integral. And then over here we have the indefinite integral of 3 cosecant x cotangent x, and we can multiply and divide by -1, so we get the negative integral of -3 cosecant x cotangent x dx, and hence that becomes negative, and then we recall that the integral of negative cosecant x cotangent x dx is just going to be equal to, we said that this is equal to cosecant x, if I recall, so this is -3 cosecant x plus c. That's correct, right? Cosecant of x, yeah, okay. And then finally here we have a definite integral now, the definite integral from 0 to pi over 4 of 10 secant squared of x. We remember that the derivative of tangent of x is secant squared of x, and hence this will be 10 tangent of x, and we don't need to include a plus c because this is a definite integral, and we're going to evaluate this from pi over 4 to 0. So that's equal to 10 tangent of pi over 4 minus 10 tangent of 0. We know the tangent of 0 is equal to 0. Tangent of pi over 4 is equal to 1, and hence this is just equal to 10. And that would be our final answer right over there. Let me fix that box a little bit. All right, so I hope this helps. I hope that, I mean, really, when it comes to integrating these trig functions, it's just all about thinking about the derivative of the trig functions and correlating them to their integrals. So it's not really memorization, it's more so just connecting this, connecting integral calculus to differential calculus.